morning, everyone. Thank you so much for joining us this morning. I am going to hand over the presentation to Doug Ross, our pneumatic product specialist, who's going to present. If you have any questions, please put them in the chat, and we'll make sure to answer those as we go along. So thank you again for joining us. And Doug, I'll hand it to you.
All right. Thanks, Sarah. Welcome, everyone. Sarah, can you hear me all right? Am I coming through?
Yeah. Yep. You sound good.
Great. All right. Well, welcome, everyone. I'm just going to, my name is Doug Grog, pneumatic product specialist here at Air Hydropower. And I just wanted to put together a short presentation or kind of overlook as to what kind of details and questions need to be asked for when you're going to size a valve for an application. And so by no means is this, in the weeds and gets you necessarily all the information. I don't expect you to come away from here saying, I know everything about valves. It's purely just, hey, what are some of the basic questions that we need to ask to get to the details to spec these valves in. So let me get my pointer going up here. So as you can see, the four of the main categories I'm looking at are, the size of the valve, the mounting style, the function, and then of course the operator, manual, solenoid, etc. And then after we go through each one of those, then I'm just going to show you some tools I've put together for kind of getting those calculations and getting the specific size of valve that we need. So with that, let's jump right in. So the first one, getting the size of the valve. As you guys have probably run into, there's so many varieties of sizes. We're talking down to these miniature valves that can actually fit inside of the pilot valve to the pilot valve that controls these larger 1.5 to 2 inch ported valves. So with the large range of sizes, then obviously we've got to nail that down. So typically, you're called up whatever the need is, and you already know the port size, which is a great start. The CV value is one that is very helpful. And so while I never expect anyone to know the CV value, sometimes they know from experience, hey, this valve has worked and it has a CV value of this, then that can get you headed in the right direction. What I'm going to show you at the end are some tools to use the flow rate or the operating pressure and the speed of a cylinder to get you to that CV value. Because once you've got that CV value, it's generally very easy to get to find the right valve, because these valves, just as when you've thumbed through a Mac catalog or looked online, the valves are categorized by CV value. So once you get there, it's pretty easy to get to the port size. So once again, the size of valve obviously very critical in determining where you're going to go. Next is the mounting. So once again, this is not. We've got 5 different types here, but this doesn't even include all the different mounting styles. But to run through these, the first style is inline. Just kind of ignore that circle for now. But for inline, what you're doing is they're hard plumbing directly into these ports. So, and then then the customer or whomever will mount this valve. You can see those through holes there. They'll mount the valve to the side of the machine, to operator panel, control panel, inside of the panel, but the air lines are connected directly to the valve. And so that's inline. An individual sub base is just where you've got a single valve and you're actually plugging it in or putting it onto a base. You'll notice I have non-plug-in and plug-in, and that goes for the bases and the manifold style. So the easiest way I can kind of try to convey this is that the plug-in style, think of it as just a you know, a 3-prong plug on an extension cord, right? And so you've got those prongs and you simply just plug that into an outlet. That's essentially what's on these valves. There are some connectors on the bottom side of these valves, and they just plug directly into the base. So all the electrical connections are actually run through the base on initial install, but then all you have to do to replace a valve is simply unplug it or plug it back into the base. Alternatively, you have the non-plug-in style for both the base and the manifold style. And this is where I circled the solenoids. You see right here and up here and over here, they all have a connection to where a wire is going to come in and actually connect directly to each valve. So for instance, on this valve manifold, it's a non-plug-in, and so you have to bring an electrical connection to each individual solenoid on that manifold. So if you want to replace this valve, you have to take it off and then unplug this this connection or undo that wire, and usually you just unplug that connection. Whereas in the plug-in style, you run all the wires initially, and then all you're doing is taking on and off the valve. But I don't expect you to remember and know all this. The main focus is understanding that asking the question about, hey, how is your valve mounted is very important because of all the different potential options here. So once again, just pointing out the importance of asking that question about how is your valve mounted in your application, or just knowing that. Moving on to function. So here's where you'll typically hear someone say, hey, I need a 3-way 2-position valve, or 4-way 3-position valve, 4-way 2-position, 5-way 2-position, whatever the combination. So I want to just break it down into the ways and the position. And so for the ways, it just means ports, the number of ports that are on the body of the valve. And I'll get into that in just a minute, a little bit deeper. But as you can see, if you were to look at the diagram of the valve, which is I'd say always on the side of a valve, or when you're looking it up online, you're going to see a little schematic, and you'll see that in one of these boxes, you'll be able to tell how many ports or ways there are for the valve. And so on here, you can see there's 1 port, 2 ports, 3 port, 4 port. Here, 1, 2, 3, 4, 5. And so just a simple understanding, the number of ways equals the number of ports. Now to throw a curveball in here, now one tricky part that it took too long for me to kind of grasp this area when I was getting started, but understanding that for the most part, a 4-way and a 5-way are the same thing. The 5-way has an extra port for exhausting, but 9 times out of 10, they're used in the same applications, a 4-way and a 5-way. It is primarily the design of the valve or the manufacturer that determines, or is it going to be actually 5 ports or 4 ports? But the function is almost always the same. And I'll get into a difference here right now. So for instance, 4 ways equals 5 ways, right? Most of the time I said. And so here's comparing the two different setups. The 5-way or 5 port, 1, 2, 3, 4, 5. Okay, so we're just counting in one box how many ports. And so as you can see, you've got an inlet, that's number 1, and you've got 2 working ports, so number 2, number 3. And then you see you've got EA and EB. That just means exhaust for port B and exhaust for port A. So that's where you can see your 1, 2, 3, 4, 5 ports. Okay. Now we go over to the 4-way, and you can see we have pressure in, we've got 2 working ports, and just 1 exhaust port. And so there you've got a 4-way. Okay, 4 ports, 4 ways. However, they're both acting in the same manner, to where you, in one position, you're energizing A and exhausting B, and in the second position, you're energizing B and exhausting A. And if you go back over to this 5-way, you can see we're doing the same thing. In one position, we're pressurizing B to start, in this case, and exhausting A. And in the second position, we'd be energizing A and exhausting B. So the same function is created from both valves. It's just one additional port for the exhaust. So I know that can get confusing, but hopefully I've shed a little bit of light onto why sometimes when you go to a valve manufacturer, they'll say, oh, this is a 4-way. And other times you'll go to manufacturers, a lot of valves out there are labeled as a 5-2 or a 5-3, when in reality it's actually being used the same way as a 4-way valve. So so it's just important to understand that and ask that question from your customer. Hey, how many ways? What's the function of this valve? So the next part of that, ways and positions, is of course the position side of it. And positions are just the number of blocks or physical positions of the valve. How many operations does that valve have? And when you're looking at a schematic, as you can see, from before, here you have 2 blocks. And so of course that's going to mean a 2-position valve. And the same for a 3-position. If you've got 3 individual blocks, it's a 3-position valve. And here are some examples. So before we were just looking at one single block to determine the ways or ports. And then when you want to determine how many positions, that's when you're counting up how many blocks are in the total valve. So here you've got 2 blocks for a 2-position, and then over here you can see there's 3 individual blocks for your 3-position valve. And so once again, all I'm trying to do is to simplify it. There's a lot of other details on these valves, but I just want to simplify the idea of, okay, what does 2-way, 3-way, 2-position valve mean? And so in this valve, for instance, we have 1, 2, 3 ports. So it's a 3-way, 2-position valve. And here, you've got 1, 2, 3, 4, 5. So a 5-way or 4-way, 3-position valve. Same thing down here with the 5 ports and 3 positions. And over here you can see we actually have 1, 2 ports in a block. So that is a 2-way, 2-position valve. I don't see any questions so far. Good, good, good. So moving along, as I mentioned, 2-way, 2-position. So the big use here, primary use, is on-off, right? If someone says, hey, I just need a valve it's an on and off valve, or it's a valve that's starting up my system and then turning it off, a lot of times you're going to be looking at a 2-position valve. The next popular one is a 3-way, 2-position valve, and these are most commonly used actually in a single acting cylinder, and I'm going to show you that here. So so as you can see right here, now when it's energized, the operators push the button, you've energized the valve, and now you're pressurizing the cylinder to extend it. And it's single acting because you're only acting in one direction, okay? The other direction is using a spring to return. And so now you'll see when they let their finger up, then that spring pushes that cylinder back and retracts it. And these can be set up in either way, these cylinders. Sometimes they have the spring on the piston end and sometimes on the rod end. But either way, you're dealing with a single acting cylinder. And so you only need to apply pressure and then exhaust the pressure. And so you only need three ways for that, and generally 2 positions. So then on to the 4 or 5 way and 2 and 3 position double acting cylinders. So here's the first one I'm going to show you, which is a 4-way or 5-way 3 or 2 position valve for a double acting cylinder. So you'll notice that there's no middle ground. You're either extending the cylinder or retracting it. There's no way to stop the cylinder mid-stroke. So you can see you energize and the cylinder extends, and you de-energize and it goes all the way back. So this is purely, hey, I'm either all the way out or all the way in. There's no stopping in between with a 2-position valve when you're using it on double acting cylinder. Now, if you do need to stop it mid-position, then that's where you go with a 3-position valve for a double acting cylinder. And here you'll notice we energize it, we go all the way down, and here you can tap it just a few times and it'll tap and move up, but anytime you release, it goes to this center position. And in this center position, all the ports are blocked. And so all the pressure that's built up in these lines is gonna be maintained in there. And so that cylinder is gonna hold position with a blocked center valve. And there's different types of centers. There's open center, pressure centered, and that's for another time. But for today, the primary goal is to understand that it's important to ask the question of how many ways and positions to understand what kind of function you need this valve to have. All right, so the last kind of key category for getting information is what type of operator. Okay, so are they dealing with a manual operator where you're actually using it with your hand or foot, a mechanical operator, or a solenoid valve? And of course, 1 or 2, whether you have, just 1 operator or sometimes double solenoid or even 2 hand levers. There's really you're only going to have 1 or 2 of those for your operators. And then a detent in any position. And we'll get into that detent as well. It's basically just holding the valve in that position whenever you move it there. So the first one is the manual valves. Once again, lots of options here, and there's many more beyond this. Just wanted to emphasize the importance of asking this question of what is your operator? And then once they say, hey, I've got a manual operator, well, what type of manual operator is it? And they can, then they should be able to drill down. Well, it's a push button. Okay, great. Are you pushing or pulling? And you can start going from there. But you've got to know to properly identify a valve and to get the right valve in there, you've got to know the details on the operator. And as I mentioned before, the detent. Do they need a detent in any of their positions? And this just holds the position. So for instance, sometimes on a safety valve, if you've got a soft start or a quick exhaust valve that you're using as a safety lockout, you'll push down that button and it'll detent down to where it stays down there. If you let off the button, that button stays down there to keep all that air exhausted. And so that's a great example of what a detent is. It holds it in position until you go back and you have to physically pull that knob up. And so that's all we're looking for, as well as the options and understanding of it if they need a detent on their valve. Getting to mechanical operators. Once again, lots of different operators here. There's a pilot operated, different incoming pressures. If you've got different You have to change the pressure to operate your the spool valve. Plungers, these are excuse me, different just all these different roller cam levers that, if you've got a valve on a machine, on a moving component of a machine, then sometimes that valve will actually come up to a hard stop, and as it approaches the hard stop, then that's where that roller will be engaged, and then as soon as that's engaged, then it sends air to another function. So maybe in a clamping situation, maybe your cylinder comes down, and as that cylinder is coming down, there's a valve on it, and when it reaches the bottom, then it actuates a clamp that comes down and clamps onto the part. And so it's another way of kind of automating that people will tend to use for automating without getting into electronic controls. And then on to the more popular, ever so more, is the solenoid valves. So here, just some kind of, overall questions, high-level questions is the voltage. Typically it's going to be your 24 to 120, and then wattage if they're limited. Sometimes, usually it's not that big of a deal, but every once in a while they say, hey, listen, I can only have so much wattage on this valve. So it's just something to be mindful of. And then of course that connection. Going back to the original mounting style, you'll remember that, some of them, they had it connected where all the wiring was going through the base, so that they didn't have to worry about any plugs or flying leads, where sometimes you want to have the flexibility of having the flying leads to change out different, if you're prototyping, for instance, maybe you have completely different valves. And so you don't want to have to deal with the same manifold setup. You want an inline valve with a flying lead. So it's just important to understand what kind of connection there is. And then I also put on there Ethernet IP, as this moves you into a different category of valve selection. Protection from water, if that's needed, if there's a specific IP rating that they need, whether it's for going into the food industry or if it's going to be outdoors, then that's going to be needed to know up front, so that there's the proper protection on that valve. And then of course hazardous location. Some might say, hey, I need a 24-volt valve, and it's just instincts that, hey, they're not used to saying, hey, I need it in a hazardous location. This is one, so I need it to be intrinsically safe or explosion proof, whatever that might be. So it's just important to ask that question. Hey, is this in a hazardous location? And then they should be able to provide you more information as to what it needs to comply with. So then, so we've gone through kind of some, the main details or questions that we need to be asking to get down to determining the correct valve. So the size, the mounting, the function of the valve, and the operator. And so then the last is what I use, some tools that I use for sizing. And so I'm going to jump out of my presentation real quick and over to here. So this is just a little spreadsheet that I've compiled from tools, from vendors, from other colleagues. And so the first one is determining that CV that I discussed in the very beginning, from understanding the movement of the cylinder. So as you can see here, you can simply just type in your bore diameter. So I'm just going to say, hey, I want a 2-inch bore, cylinder stroke 12 inches, rod diameter 1 inch, and we want that to move, and you'll see one way. So extend or retract, just one, not a full cycle, but just moving out. And so I want it to be able to extend in 1 second. And you can input your pressure here and the valve pressure drop. So here I would tend to just leave this go at the 10 psi. If you know what that pressure drop is, go ahead and put that in, but you should be good just leaving that at the 10. And then what you can see here is by inputting that information, you right away you get the output of your required CV. So right here, this is going to lead you directly to what size of valve you're going to need and what port size is going to be best fitted for you. Additionally, this tool gets you some information on just cylinder volume, and maybe even more important here, your extend and retract forces. So this I'll use, I've got a little app too, but sometimes if I'm in here, this makes it pretty easy to be like, okay, if I know I need 500 pounds of extend force, oh, okay, well, 3-inch bore, that's going to get me there. I'm happy with that. Got a little bit of a factor in there, so it just gives you a little bit room to play with there. And also understanding, okay, well, if I don't want 100 psi, but I want to go down to 60 psi, well, okay, now I'm well below that, so I need to bump my bore size up. And so it's just a neat, handy tool that allows you to get a good amount of information from what the customer or yourself or whomever should already know, which is your bore diameter, your stroke, the rod diameter, and how fast you want it to move. On almost any machine that you go out there, you're going to be able to understand this information fairly quickly with the inlet pressure. And so with that, you can pull, okay, what are your forces, what's your SCFM, and what's that CV factor for you. Another thing I added here was just for kicks. If you've got a system that uses multiple cylinders together in line or in series or anything, and you just put your number of actuators there, and now okay, how much do I need for my total flow going through there? So that way you can make sure to size your air prep accordingly. So another tool on this is just a converter, and this has got multiple converters on here. So if you know the SCFM, then once again this can get you to your CV, and that's why initially I told you it's important to know your air pressure, right? Because here you can look up your air pressure. Hey, I'm running at 90 psi. Great. This is my factor, my 0.0192. And this whole thing explains it, but pretty easy. You take that flow rate, let's say you've got an air tool, right? And so your air tool uses 27 SCFM. Well, and you're running at, in this case, 100 psi. And so you can just multiply those, and there you get your CV. So you need a valve that'll handle 0.48 CV. And so fairly quickly, you can hone in on what size valve you need for your application. And so, here's another converter, CFM to SCFM. But really, these two right here are the primary tools that I use on a regular basis for getting to that right size. And these are two tools that I'm going to be sending out to all the people that registered or are on this event today. I'll be sending out a spreadsheet to those people with these tools on it for you to use. And please, give me feedback. Let me know if there's other things that you'd like added to it. I'd love to hear from you. But I think with that, I'm all set. If there's I don't see any questions. So with that, I think we are good to go. Thanks for joining.
Thank you, Doug. I appreciate that. And if you guys have any questions, feel free to put them in the chat. And I think we just got one question. Let's see. Oh, that was just a thank you. So, and well, thank you all. And I'll send out Doug's information in case you have any other questions. Doug, we have one question. Can we get your initial PP?
Yes.
That was
yes.
for you.
Yep, absolutely. Yep, I'll send out the PowerPoint as well. Josh, I'll have that. The PowerPoint will be on our SharePoint drive for you. Great. Glad you liked it, Josh.
All right. Well, thank you, everyone, and have a good day. Thanks,
All right.
Ted.
Thanks, Sarah.